Hi there. In this video, we're going to be talking about triangle inequalities. Now, in order to talk about the inequalities of a triangle, what we have to know is this thing called the triangle parts relationship theorem. All right, and that's a whole bunch of hoopla that I don't really want to get into. But basically, to put this into the easiest terms to understand, the smallest side in a triangle is opposite the smallest angle. The largest side is opposite the largest angle. Okay, and so let me draw a picture of a triangle with angle measures and side lengths so that we can see what we're working with. So given a triangle like this, we've got triangle ABC, or I'm sorry, ABC. All right, and we've got the side lengths in here, and we've also got the angle measures. Now, what I want to talk about is analyzing these side lengths. All right, so let's talk about the smallest side length. Okay, here's my smallest side length. Here's my smallest angle measure. What I know is that angle B is the smallest angle measure of 30 degrees, and it's across opposite of the smallest side. All right, so angle B is my small angle, but then we'll call segment AC our smallest side length. Okay, now let's go through and talk about our medium. All right, so our medium side length is 12 and our medium angle measure is 62. All right, so we have small, medium, and what I know is that these are across from each other. All right, so 62 degrees is across from the side length of 12. These are both the middle measures. All right, so I'm going to write angle C is our middle one, and length AB is our large one, or is our medium side length. Okay, let's talk about the large angle and the large side length. So the only one left is 88 and our side length of 16. And what we can say is that the longest length that we have in this triangle is opposite our largest angle. Okay, so what I can say here is that angle A is our large angle, and side length BC is our largest side. So what I can do is I could write some inequalities here, all right? And we can order this from shortest to largest. And what we can say is that, like, you know, angle B is less than angle C, which is less than angle A, okay? And that's the idea. And if you come in here, you can say, all right, well, 30 is less than 62, which is less than 88, you know, and that's what we're showing here, all right, and ordering these from smallest to largest, all right. And we can do the same thing with the side lengths, all right. We can say that, like, side length AC is less than side length AB, which is less than side length BC. That's the largest. All right, so AC had a length of 7. That number is smaller than 12. All right, and that number is smaller than 16. And that allows us to write these statements here. All right, so given an example, what it wants us to do, given this picture, is order the sides from smallest to largest. So what we can do here is simply look at this triangle here, and all we're given is angle measures, but we're trying to figure out how to order the sides from smallest to largest. So what I want to do is look at my smallest angle, okay? So my smallest angle is 30 degrees, all right? And that's going to be across from the smallest side. So this side length here is going to be my small side. Now the next angle measure, the medium sized one, is 60 degrees because this one's 90, all right? And if I look at that one, this is going to be across from my medium sized side length, okay? And the last one we want to look at is our 90-degree angle here, and that's our largest, and that's going to be across from the largest side, and that's going to be this length. So if I wanted to actually order the sides from smallest to largest, I would simply say side length AB, all right, because that's our smallest, all right, so I would say that AB is less than the medium side, which is BC, and then that's going to be less than our large side, which is the side length AC. And this is the answer, and this is how we would order our sides from smallest to largest. Okay, on this problem, I want you to order the angles from smallest to largest. Now, in this picture, you're only given the side lengths. All right, now what I want to do is locate my smallest side length, and that's this length xy, which is 5. All right, so this is my smallest, and that's going to be across the opposite of my smallest angle. All right, so angle W is going to be the smallest. Now let's look at our medium-sized one. All right, medium-sized one was 7, and that's going to be across from our medium-sized angle measure. All right, so Y is our medium-sized one, and our last one, our longest side is side 11, and that's going to be opposite our largest angle, which is going to be X. Okay, and you can kind of tell just by the picture. All right, it's hard to tell with angle W and angle Y, but you can definitely tell with angle X that this is our largest angle, okay? So if we come over here, we want to order the angles from smallest to largest. I'm simply going to come over here and write that angle W is less than angle Y, which is less than angle X. And that's how we would order those from smallest to largest. The last thing I want to talk about today is the Hinge Theorem. And what this states is that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is larger than the third side of the second triangle. Yuck! Let's draw a picture. Okay, so if I have these two triangles, all right, and let's look at what this says. If two sides of a triangle are congruent to two sides of another triangle, that's these symbols here. AC is congruent to FD, and AB is congruent to DE, all right? So these two pairs of sides are congruent from one triangle to the next. The included angle between these two sides here is 40 degrees. And then this one, it's 52 degrees, all right? So what I know is that the included angle of one triangle is larger than the included angle of the second triangle. So here, what I know is that this angle is larger than this one, all right? So here's what I know, is that this angle is going to be large and this angle is going to be small. Therefore, because these two sides are congruent, we can now guarantee that side length CB is going to be less than side length FE. All right, that's the conclusion that we can draw simply based on the Hinge theorem. Now, you can take the converse of the Hinge theorem and talk about how if these sides are congruent and you know that CB is smaller than FE, then you can conclude that angle A is smaller than angle D, okay? So basically, you're just showing that, you've got two triangles that look like they're gonna have the same side lengths and angle measures, but in actuality, they don't. They've got some, and we can analyze the lengths and compare the lengths between the third sides, and that's what the Hinge theorem does. Hope you enjoyed this video, and we'll talk to you soon. Thanks, bye.